algebra students, this is our introduction video for our lesson on graphs of functions in standard and factored form. The goal of this lesson is going to be to find the connections between equations of quadratics and the graphs. For example, you already know some connections. You know, for example, in equations like these, linear equations, this represents your y-intercept and this represents the slope. There are similar connections for our equations of quadratic equations. So to help us go over these connections, we have these three graphs here. The first thing I want you to do is pause the video and identify the x-intercepts and the y-intercepts of these graphs. If you have two different colors, it might be helpful to mark those points in two different colors. Go ahead, pause the video, and do that now. All right, got all our points labeled here. The y-intercepts are all in purple, so we have a y-intercept at 4, at -9, and at 0, and our x-intercepts are all in green. We have x-intercepts at 1 and 4, at -3 and 3, and then here that point 0 is your x and your y-intercept, so x-intercepts for this last one at 0 and 5. Our goal is going to be to find connections between these graphs and our equations in standard form and in factored form. So starting with these equations here, which form are these equations in? Standard form. I'm curious if you can find any connections between these equations and the graphs above. So for example, x squared minus 5x plus 4 represents this first graph, x squared minus 9 is the second graph, and so on. Pause the video if you need to and see if you can find any connections. When we look at standard form of equations, there's connections you can make between these equations and the y-intercepts. So for example, a y-intercept of 4, -9, and 0. All of those y-intercepts we can see in standard form by looking at the constant. So for example, this first one, our constant is a positive 4, and my y-intercept is a positive 4. For that second one, my constant is a -9, and my y-intercept is at -9. For that last one, I don't see a constant, which means my constant is 0, and our y-intercept is at 0. Looking at standard form helps you know where your y-intercept is. And that's very similar to what you already know about linear equations. The constant is the y-intercept. Let's do the same thing now, but look at factored form. So each of these equations I have in factored form below, and we want to do the same thing. See if you can find some connections between factored form and the graphs. Pause the video now and then come back when you've got an idea. As we're looking at factored form, you might notice some similarities between the numbers you see in factored form and your x-intercepts. But something is just not quite right. For example, this one says x minus 4 and x minus 1, and our x-intercepts are at 1 and 4. Over here, I see the same numbers. Over here, kind of. And so the way to see those connections is going to be by focusing on the other number for these x-intercepts, which is that y-coordinate of 0. If I gave you factored form and you needed to find these x-intercepts, we see it's the same number there, but the way to figure out the sign is by actually solving a small equation. For example, if I have x minus 4 and x minus 1, notice that the y coordinate is 0. We would want to solve x minus 4 equals 0 and x minus 1 equals 0 to help us find where those x-intercepts are. And if you do that, you add 4 on both sides and you add 1 on both sides, and you get those x coordinates we see on this graph. Similarly, for the second equation, you would be solving x minus 3 equals 0 and x plus 3 equals 0, and that would give you x-intercepts at 3 and at -3. This last one here can sometimes be the trickiest for students, but there are two parts that you can set equal to 0. You're going to set x equal to 0, which is already solved. That's giving us this x-intercept here, and then that 5 minus x equals 0. When you solve this equation, I'm going to add x on both sides to bring my x over to the right side and make it positive, and we get that x-intercept at 5. This is going to be really important for the work we're doing in these final lessons on graphs of quadratics. There are two main ideas. First, how do you find your y-intercept? You need to look at your standard form. And when you look at your standard form, the constant is the y-intercept. So for example, if I gave you the equation in standard form, y equals x squared minus 5 plus 3x, we can look at that and we know our y-intercept is going to be negative 5 because it is our constant. If you want to know the x-intercepts, that's what we did in the second part here. You need to look at factored form. And when you look at factored form, you set each factor, that's the parentheses, you set each parentheses or each factor equal to 0 and solve. So for example, if I gave you the equation y equals x plus 3 and times 8 minus x, you'd be setting x plus 3 equal to 0 to find an x-intercept at negative 3, and 8 minus x equal to 0 to find an x-intercept at 8. We're going to do more practice on this in today's lesson, but this main idea right here, this is going to be super important for the work we're doing today and in some future lessons. Thanks so much for watching.